We are witnessing a revolution in the world of machine learning, brought about by an innovative approach known as self-supervised learning. This blog post aims to shed light on this groundbreaking concept, explaining its importance, its mechanism, and its impact on the tech industry. Ready to dive into the future of machine learning? Buckle up and let's go. Understanding self-supervised learning. Let's start by defining what self-supervised learning (SSL) is. It's a type of machine learning where the model generates its own labels from the input data, thereby learning without the need for explicit human-provided labels. This differentiates it from traditional supervised learning, where a model is trained on a labeled dataset, and unsupervised learning, where the model looks for patterns in unlabeled data. SSL's significance in the world of AI cannot be overstated. It is a game changer because it allows machines to learn more efficiently by leveraging the vast amounts of unlabeled data available. According to industry estimates, more than 80% of data is unstructured or unlabeled, making SSL's potential immense. 2. The mechanism of self-supervised learning. To grasp how self-supervised learning works, let's take an example. Imagine a child learning to identify animals. They are not explicitly told which animal is a cat or a dog. Instead, they observe and compare animals' features, gradually developing the ability to distinguish between different species. This is similar to how SSL works. It provides AI with the capability to learn from raw, unlabeled data by creating artificial labels and using them to train the model. For instance, an SSL model might learn to recognize objects in images by predicting the color of the next pixel in an image or the missing word in a sentence. This kind of learning is akin to solving a jigsaw puzzle, where the model learns to recognize patterns and features through the process of fitting the pieces together. 3. Advantages of self-supervised learning. Self-supervised learning offers several benefits that make it a desirable choice for machine learning practitioners. First, it efficiently utilizes data. As mentioned earlier, most of the available data is unlabeled. SSL provides an effective way to make use of this vast reservoir of information. Secondly, SSL systems are more accurate, since they learn from the underlying structure of the data rather than relying on human-labeled data. They can uncover more nuanced patterns and relationships. Research has shown that SSL models can outperform their supervised counterparts in certain tasks. Finally, SSL is cost-effective. Labeling data is a labor-intensive and costly process. With SSL, the need for human annotated data is minimized, reducing the cost and time needed to train a model. As we delve deeper into the world of self-supervised learning, it's important to remember that while it offers many advantages, it also comes with its unique set of challenges and limitations. But that's a topic for the next part of this series. Stay tuned as we explore the potential pitfalls and real-world applications of self-supervised learning in our upcoming articles. Let us pick up right where we left off. In Part 1, we explored the basics of self-supervised learning, SSL, how it functions, why it is unique, and the game-changing advantages it brings to the world of AI. But, as with any transformative technology, SSL also has its own hurdles and considerations. Let us dive into some of these challenges before looking at how SSL is already making waves across industries. IV. Challenges and limitations of self-supervised learning. While self-supervised learning has opened many doors, it is not without its roadblocks. One of the biggest challenges is designing pretext tasks of the AGA-MESA or proxy objectives that the model learns from before tackling the real problem. If the pretext task does not encourage learning features useful for the final task, SSL may not deliver its full promise. For example, predicting the rotation of images may help in some vision tasks but not others, depending on the context. Another challenge is data quality. SSL relies heavily on the assumption that patterns within the data can be discovered without explicit labels. If the data is too noisy, unbalanced, or lacks meaningful patterns, SSL may struggle to learn anything useful. And while SSL can reduce the reliance on labeled data, it often requires large volumes of unlabeled data and significant computational resources for training. Interpretability can also be an issue, since SSL models create their own labels and learn features that may not always be human interpretable. Understanding why the model makes certain decisions can be difficult. This is especially important in fields where explainability is crucial, like healthcare and finance. Despite these hurdles, researchers are actively working on improving SSL techniques, creating more robust pretext tasks, and developing better evaluation metrics. The field is evolving quickly. What might be a challenge today could be solved tomorrow. Real-world applications of self-supervised learning. Now for the fun part of how SSL is already reshaping various industries. The versatility of self-supervised learning means ITS being adopted in some really exciting ways. Natural language processing, NLP. Perhaps the most well-known success story comes from NLP. Models like BERT and GPT. Yes, the same technology powering this blog. Use self-supervised tasks such as predicting missing words in sentences or next sentence prediction. This approach has led to massive improvements in tasks like translation, summarization, and question answering. Computer vision. In image and video analysis, SSL has enabled models to learn visual features without labeled datasets. For example, SSL models can learn to recognize objects or detect anomalies by predicting missing parts of images. Colorization, or image rotations. Facebook, Google, and OpenAI have all leveraged SSL to train large-scale vision models. Healthcare. With vast amounts of unlabeled medical data. Think X-rays, MRIs, EHRs. SSL is helping build diagnostic tools that can spot patterns or anomalies without extensive annotation from medical professionals. Speech recognition. SSL has also found a home in audio processing. By learning from raw audio data like predicting future audio frames or reconstructing masked segments of these models improve speech recognition and even music recommendation systems. Robotics. Robots are being trained using SSL to understand their environments by predicting the consequences of their actions, making them more adaptable and efficient. These are just a few examples, but the list keeps growing. As new SSL methods emerge, we can expect even broader adoption. Statistics and data. The numbers behind SSLAS rise lead us put some numbers to all this excitement. Growth in research. According to Google Scholar, the number of academic papers mentioning a self-supervised learning has skyrocketed in recent years, up over 500% from 2017 to 2023. Industry adoption. A 2022 industry survey from O'Reilly found that 37% of companies developing AI solutions have experimented with or deployed self-supervised approaches, up from less than 10% just 3 years earlier. Performance benchmarks. In vision tasks like ImageNet classification, SSL models such as SimCLR and MoCo have matched or surpassed supervised models, achieving top 1 accuracy rates of 76.5% and higher. Impressive considering they used no labeled data for pre-training. Cost and data impact. ITS estimated that data labeling can account for 60 to 80% of the time and cost in a traditional AI project. SSL, by reducing this need, can lower overall project costs by up to 40%. According to a 2021 McKinsey report, NLP milestones. Large language models like BERT, trained with SSL methods, have achieved state-of-the-art results on 11 major NLP benchmarks. According to the original BERT paper, what do these stats tell us? Simply put, SSL isn't just a research curiosity, it's a practical, impactful technology that is already accelerating progress across the AI landscape. As we've seen, self-supervised learning is both powerful and multifaceted, with real challenges but even bigger opportunities. In the next part, we'll lighten things up with some fun facts about self-supervised learning, spotlight a pioneering researcher, and answer your most burning questions. Stay with us as we continue unraveling the fascinating world of SSL. Part 3. Welcome back to our series on self-supervised learning. We've discussed the fundamental concepts, practical applications, benefits, and challenges of self-supervised learning. We've also looked at some impressive statistics that demonstrate its growing traction in the AI world. Now, let's take a more relaxed approach and dive into some fun facts about self-supervised learning. After that, we'll spotlight an influential figure who has made significant contributions to this field. Fun facts about self-supervised learning. Not an entirely new concept. Although the term self-supervised learning is relatively new, the idea of learning from unlabeled data has been around for decades. Inspired by human learning, much like how children learn from their environments without explicit instruction, SSL models learn from raw, unlabeled data. Language superpower. The language model GPT-3, which uses self-supervised learning, has 175 billion parameters, making it one of the largest and most powerful language models in existence. SSL in art. SSL isn't just for scientific endeavors. It's also being used in creating music and art. OpenAI's MuseNet, a deep learning model that generates music, employs self-supervised learning. It's in your pocket. Self-supervised learning techniques are used in everyday applications like speech recognition in smartphones and recommendation systems in streaming services. From games to learning, some advanced SSL algorithms learn by playing games, such as predicting the next frame in a video game, helping them understand complex dynamics and rules. SSL and social media. Major social media platforms use SSL to optimize their algorithms. Feed personalization and content recommendation. A favorite of giants. Tech giants like Google, Facebook, and OpenAI have all made significant investments in self-supervised learning research. SSL in space. NASA is exploring the use of self-supervised learning for autonomous space exploration, where the availability of labeled data is limited. SSL and the pandemic. Self-supervised learning has been used in the fight against COVID-19, helping to detect patterns and anomalies in chest X-rays and CT scans. Author spotlight. Yann LeCun. In the world of self-supervised learning, one name stands out: Yann LeCun. LeCun is a computer scientist known for his work in machine learning, computer vision, mobile robotics, and computational neuroscience. He is a Silver Professor at the New York University, NYU, the founding director of Facebook's AI Research Lab, and, notably, a recipient of the Turing Award, informally known as the Nobel Prize of Computing. LeCun has been a prominent advocate for self-supervised learning. He has done extensive research on the topic and is a strong believer in its potential to move AI forward. His work has greatly influenced the development and acceptance of self-supervised learning in the AI community. LeCun's vision for AI is one where machines can learn from observation and experience, just like humans, and self-supervised learning is a big part of that vision. LeCun's contributions have not only advanced the science of AI but have also helped bring powerful AI capabilities to everyday applications and services. His work continues to inspire researchers and practitioners in the field of AI and self-supervised learning. So far, we have journeyed through the technical aspects, real-world applications, benefits, challenges, and interesting facts about self-supervised learning. But we know you may still have questions or want to dive deeper into certain aspects of this fascinating AI technique. So, in our next part, we'll focus on the frequently asked questions about self-supervised learning. Join us as we continue our exploration of this innovative AI practice. Part 4, as we close up our series on self-supervised learning. SSL. We dedicate this final part to addressing some common questions you might have about SSL. Let's further unravel the mysteries of this transformative AI learning technique. FAQ section. Self-supervised learning 1. What is the difference between self-supervised learning and unsupervised learning? While both methods learn from unlabeled data, the key difference lies in the learning process. Unsupervised learning uncovers hidden patterns or structures within the data, while self-supervised learning creates artificial labels from the data, using them to guide its learning process. 2. Are there any potential risks or ethical concerns with self-supervised learning? Like all AI techniques, SSL can be misused if not properly managed. For example, if SSL models are trained on biased or sensitive data, they might learn and perpetuate those biases. Transparency, accountability, and strong ethical guidelines are crucial when deploying any AI solution. 3. Can self-supervised learning completely replace human supervision in machine learning? While SSL reduces the need for labeled data, it doesn't entirely eliminate the need for human supervision. Humans play a critical role in curating and validating the data, defining learning tasks, and interpreting the results. 4. How is self-supervised learning used in healthcare? SSL is being used to analyze medical imaging data, such as X-rays or MRIs, where it can learn to identify patterns or anomalies without extensive labeling by medical professionals. This can help in early detection and diagnosis of diseases. 5. What are the hardware requirements for self-supervised learning? SSL often requires substantial computational resources, especially for large-scale tasks. This includes powerful processors, like GPUs, sufficient memory, and sometimes distributed computing environments. 6. How is self-supervised learning related to reinforcement learning? While different, they can be combined. In such cases, SSL can be used as a pre-training step to learn useful representations of the data, which are then fine-tuned using reinforcement learning. 7. Can self-supervised learning be used with smaller datasets? While SSL can work with smaller datasets, its strength lies in leveraging large amounts of unlabeled data. With smaller datasets, the benefits of SSL might not be as noticeable. 8. Can self-supervised learning be used in conjunction with other learning methods? Yes. SSL can be used alongside other methods like supervised learning in a multitask learning setup or as an initial pre-training step to extract useful patterns from the data. 9. What future developments can we expect in self-supervised learning? We can expect more sophisticated SSL algorithms, improved performance on various tasks, broader adoption across industries, and solutions to current challenges like data quality and interpretability. 10. Where can I learn more about self-supervised learning? You can follow the work of leading researchers like Yan LeCun, read papers on arXiv, or check out blog posts and tutorials on websites such as Towards Data Science, Medium, and the OpenAI blog. As Proverbs chapter 1 verse 5, NKJV, aptly puts it, a wise man will hear and increase learning, and a man of understanding will attain wise counsel. The exploration of self-supervised learning, like our pursuit of wisdom, is ongoing and limitless. Strong conclusion: the journey we've taken through the landscape of self-supervised learning has been enlightening. We've seen how SSL, an AI technique inspired by human learning processes, is revolutionizing the way machines learn. From understanding its mechanism, examining its advantages, acknowledging its challenges, to spotlighting its real-world applications, we've unraveled this fascinating field in depth. The transformative potential of self-supervised learning is undeniable. As research and experimentation continue, we can expect more breakthroughs and innovative applications that will push the boundaries of what machines can do. While we've wrapped up this series, remember, learning is a lifelong journey. Continue exploring, questioning, and discovering. As we've seen in this series, the world of AI and machine learning is a treasure trove of knowledge waiting to be unearthed. For further readings and expert insights on AI and machine learning, head over to Outreach, AI Research blog. Till our next exploration, happy learning. Struggling to learn AI on your own? Best-icourse.com offers a clear path forward.